Okay, so in this video, we will do this question climbing stair. It is an easy type of question, and let's see what is written here. So you are given you are climbing a staircase, okay, and it takes n step to reach at the top. So you have to reach at the top of that staircase, and there are n number of staircase. So it will take n steps to reach there. Okay, each time you can either climb one step or two steps. Suppose you have three staircase. Suppose you have three stairs. So there how many ways you can jump them. So first way you can jump one step, then second, then third, or you can directly jump two step, then one step, because maximum step you can jump is two, you can climb is two, or either one. Okay, so let's see how we can do it, and let's see first example. What are the example given here? Suppose there are two stairs, so there are two number of ways. Why? One step or directly two step. Suppose if three stairs, then one step means three step of one. Okay, or one step and then two step, or two step then one step. Okay, like this. So I'm taking again this three example because we will have to make a less recursion tree for this, okay, if compared with others. So suppose we have taken this three. So what I will do, you can apply backtracking here. How? Let me show you. So if suppose you have three stairs, okay, so first time you can uh, you can either climb one stair or two stair. Yes, you can either climb one or two. Okay, so perfect. So if we climb one stair, our sum, I'm counting the sum is right now 1. Then in this one also we are making a recursion tree by using backtracking. So in this sum also we can climb one stair or two stair. So this sum will become we are calculating sum for each node. So in this one all as well we can climb one or two. So if you see, I'm changing this color and I'm changing its length. Yes, if you see, sum of this is 3. Okay, sum of this is 3, this node. So this node can be our answer. So our answer, suppose if I have variable a is equals to answer is plus plus. Okay, we got one answer. Then we will try with this node. See, sum of this node is 2 plus 1 plus 1, so it is 4. So this node cannot be our answer, so we will not do anything after this. Now we have traversed this node, now this is left. Okay, this is left. So if you see it, 2 plus 1 is 3, sum is 3. Yes, so we got our sum. So answer will answer plus plus, so answer we will add 1 to our answer. Okay, we will add 1 to our answer. Then this whole subtree is done, subtree is done. We are left with this. So in this again we have to take one or two, either go with this. So if we go with this 2, sum is increasing, 2 plus 2 4, so we'll not go with this. If we go this 1, so this is giving us sum 3. So this is also our one of our answer, so plus 1. So we got 3 step. So this is backtracking here. So, or if you cannot understand it like this, I can show you like this as well. See, okay. So one more way to show this backtracking is, suppose I'm okay. I'm removing this recursion tree. You can solve it like this. Either you can take one step or two steps. Suppose if you take one step, then your difference is 2. You will minus it with 3. If you take two step, your difference is 1. Then you can either take one step or two step. If you take one step, your difference is 1. If you take two step, your difference is 0. So right now here you got 0 difference because this is your one of the answer. Okay, and if you got 1, so you can either step 1 or 2. If you step 1, then your result is 0, and here result will be negative, so we'll not go to this node. And again here same with here. So we can see, we are calling this one here as well and here as well. So can you see something? We are calling this one here and here both. So we can store this result and optimize it. So this will give me what? This will give me true. Yes. And this will also give me true. Yes. So like this, we are doing same recursive call every time. Or one way is Fibonacci. You know what Fibonacci series was? Suppose you have to climb nth stair. So the nth stair will be sum of n minus 1. How many ways you can reach that n minus 1 stair, or sum of n minus 2. So code is just this, return Okay, same function. I'm copying the function name. What is this function name? Yes, this. So n minus 1 plus, solution is very easy for this question, n minus 2. N minus 2, yes. So this. So what will be our base case? If n is greater or less than equal to 2, suppose if n is 2, then number of ways is n only. Return n. Yes, perfect. So if I run it, this should run. This should run. And if it will not run, I will check. Okay, so this is running. But see, this will give you time limit exceeded by, because we are not using dynamic programming here. We are not storing a result. This will do too many recursion calls, and that will full your call stack. So we don't want that. So we will take a DP object. You can say here we will store our iterations or calls. Okay, so I will store my result here first. So if DP, my DP object is does not have store. Okay, store, not store, sorry. N minus wait, n. If DP object does not have n, then what to do? DP of n is equals to this. DP of n is equals to this. Very easy. Else just return DP of n. So this is our solution, and this will run perfectly fine. I know that. This is running. Okay, so it is not running. Let me see why. So if DP doesn't have, then DP of n is this. Okay, else. So this is giving us undefined. Why? Because we are okay. We are returning DP of n. So let DP, let DP, and we are not making DP for separate. So I should make my DP here. Why? Because we have to initialize this DP as a global variable. Each of node pair will have same DP object sharing. Okay. Okay. Now if I submit it, this will be submitted. So I tell you, you can use Fibonacci here, or you can use backtracking with DP here as well. That would all also be accepted and a good solution. So thank you so much. This was my solution. Thank you.